Now we are moving to our session two on project management. Management is the most crucial aspect in the life cycle of nuclear power plant, because a lot of things are happening here, positive as well as negative, and that's why we have a very a dedicated session for it. And with us we have uh, Mr. R. Sharan, Director Projects, to have the first address of this session. And Mr. R. Sharan has been in the DAE for he has joined DAE in the 31st batch of BRC training school. He's an engineer and an MBA, and he has worked across different technologies of nuclear power systems. So with this brief introduction, he was, and by the way, he is also a recipient of INS Medal Award given by Honorable Prime Minister of India for his contribution to the project management of Tarapur Atomic Power Plant 3 and 4, which for the information of everyone was completed in the record time of 5 years or less. So I welcome Shri R. Sharan, Director Project NPCIL, for his address on responsive project management practices, bottleneck issues, and new strategies to manage the complexities. Welcome, Mr. R. Sharan.
Respected dignitaries, delegates, I think still it is good morning, I can say. Yeah. So my topic of discussion is responsive project management practices, bottleneck issues, and new strategies to manage complexities. So I will be speaking from my whatever experience I gained in previous projects implementation. I will be covering my topic based on that. Let us see how we can capture ideas and have interaction. Next slide. So I will be covering mostly for the nuclear power project, and the topic will be introduction, practices, bottlenecks, and strategies which have been outlined in the first slide. So evolution of project management, if you see, earlier we used to be reactive in the project in the initial period of our project implementation, but that is not a preferred practice. We have to be proactive, and if we are responsive, it is the best. So best practices is that we should be responsive. Responsive means our decision making should be IT based. Means there should be data available to us. There should be past practices, and we should capture all those information, and that should enable us to take decision. And that is the responsive project management, and that has to be followed. When we were midway, we were following in between, means we were having data, but in a totally computerized manner, we were not proceeding. So now time has come that we should go in a totally computerized manner, and there are many software available in the market. For example, for 3D modeling, there are many software. For project management tools are there. Then ERP packages are there. Then product life cycle management softwares are there. So in private sector, those softwares are being used for project implementation. In public sector also, that is being used, but there is a need to optimize or have more and more involvement in those practices. Actually, our society, the young generation, which is who are coming out from the market, they are oriented towards these culture, use of software, and they are going to come in the business process, And now certainly they will be coming to the nuclear business process, and where these applications will be more useful. Actually, what we are going to do now is what we have done in the past, and we have to repeat. So optimization will be the requirement of future, and throughout the world, this optimization process is going on. So we have to capture all past practices, put in the software data, analyze those things, and proceed further. This will be the topic. I will be covering in past what we have done, and in future what we have been doing. So topic will be site related, organization and people, package formulation, contract management, change management, industries, timeline, optimization of cost and tariff. I will just hint upon some of the aspects of project management. Site related issues are also very much prominent, because it requires studies related to seismic aspects, flood studies, environmental impact studies, radiological studies, geotechnical. So many studies are there. Actually, we have done those studies in past. Now there is a need to capture those things in a structured manner. I can say there we can also capture them in the software form, in the activity chart, and try to optimize these activities, because sometimes these activities takes more than 3 years or 4 years time. That is a loss to any corporation. So we have to, or any company. So we have, there is a need to have responsive project management for site related activities. Organization and people, they are also very important, because organization is also over a period of time, it is changing everywhere. Means sometimes, for example, in case of NPCIL, design and procurement were together once upon a time. Now those departments are separated. So like that, organizational changes are being happening, and people are also very important. It's not that once organization you have developed, and you have not put people of right caliber, then that organization also fails. So we have to be very, very careful. Organization should always, an organization should always be seen with respect to responsible people, qualified people, capable people. So many words we can add, that is important. Then package formulation is very important, because this drives the project. So we have to do package formulation in a very, very careful manner, so that it meets the requirement of the project. Actually, in India, many industries are developed to a large extent. We have to capture their capability, and accordingly we have to see that how similar thing can be packaged, and then we can proceed. Then contract management is very important topic, because many of the projects takes time in execution if contract management is not done properly, because contract management is written down legal document. If we deviate, in actually in foreign country, if you deviate from your terms conditions, action will be immediate. Unfortunately, in India, if you go to court, actions are taken in many years. That's why people used to avoid going for conflict. But contract is a legal document. If you do not honor, there will be delays, because the industries who have to move fast, they will slow down your process. They will try to concentrate on some other business. So that type of risk is there. So we have to see overall perspective of the contract management, how we have to proceed. Change management is very important topic, because this happens in every project, and there are slogans that there should not be change in design, but it is not possible in nuclear industry, because anywhere in the world, if some mishap take place, it will drive change. Our regulators will also drive change. So change has to take place, and change is must. It can be design change, it can be field related change. So we have to manage the change. There are procedures. So those things can be also captured through software, and we can have responsive project management for change management also. Industries are very important, but in case of nuclear sector, what we are finding and what has been elaborated also, there has to be long-term association. It cannot happen that one industry has manufactured one component, and next time for 5 years that industry is not having order for that component. So in industry we has got many opportunities. So it happens that they will shift their uh, uh, area of working. Sometimes that experienced manpower for manufacture of nuclear component will not be available to you when you want that item to be manufactured. So there has to be long-term association with industries, and people in industries should be trained for manufacture of nuclear components. So from that angle we have to see, and timeline is also important. Actually, when you launch the project, that time is also important. At that time, what is the country position? What is the scenario, financial scenario? So many things are there, and you have to also find out how fast you want to construct the project, whether in 5 years or 4 years or 3.5 years, whether you want to go for modular construction. Many aspects are there, so that comes there. Now, optimization of cost and tariff. This is very important tariff. This is very important topic. So cost we have to optimize. That can be done only when we reduce the time, so that escalation and interest during construction, cost of financing goes down. And tariff of course, there are many methods to bring down the tariff. That is, for example, this borrowing can be done at less interest rate, return on equity can be lowered, capital cost itself can be lowered, plant life can be increased. So all these things we have got past practices. Those things have to be captured through a software. Why I am telling software? Because many things remains in memory of some person, and that person goes from the organization, and if that is not captured, you are again venturing into experiments. So those things can be avoided. So that's why I like this topic, this responsive project management. It has got capability of capturing all past practices, all past experiences, and based on that we can go for optimization. And optimization should be the slogan of the present era. And this SMR is also a type of optimization of past experience. It can come in a small reactor form, but if you go deep, you will find that it has got lot of optimization process. Next. Then negotiation. Since we are talking about indigenous technologies, so there also negotiation takes place with the various industries. But this is the slide which talks about negotiation with the foreign vendor. Once we are negotiating with foreign vendor for light water reactors or any reactor, or in future SMR, there has to be political, strategic and commercial interest. So we have to see these three aspects, and based on that only we should negotiate to get success. And also we have to see that geographical behavior of the persons. So if you see the USA, people are very, very individualistic, where in Japan they work in team. So other countries are in between. So once we negotiate with foreign vendors, we have to see these topics. So all these things are actually in some of the project management software. These things are directly or indirectly captured. Now, what is the prevailing practices? I'm not going to talk about project management, what has been written in the books. I will directly come to the nuclear industry where these things are going on. That modularization, that mechanical activities like dome and ring liner, all these things have been erected by modular construction. We are going for mega pores. These are all the optimization process. Then fragmented packages have been there. In future, we are going for mega packages. And project planning and monitoring, we were doing manually using semi use of project management software tools were used at Tarapur 3 and 4, and now at Kakrapar Rap 7 also. But in future, we are going to have use of full-fledged project management software tool, 3D modeling tool, ERP, all those things are there. Now, these are just photograph of Tarapur 3 and 4, which was constructed in 4 years, 11 months, 26 days. And these are the quantities. So, in a responsive, in a responsive manner, if you do project management, then we have to capture these quantities. And based on that, we have to make a strategy so that we get all those things done in time. Proper industries, we are having tie-up through contracts with proper industries, and similar quantities are there for Kakrapar 3 and 4. You will find that either quantities are actually more in case of concrete against 6 lakh. In Tarapur 3 and 4, it is 14 lakh. So that is mainly because some more civil structures like NDCT has been added here. So we have to see if we do not visualize the quantum of work in a project, then we cannot have a responsive project management. So that type of visualization has to be there, and accordingly we have to frame a package and tie up with industries in the form of contract or any other form, and then proceed. Then we have to go in a large manner for 3D modeling. So this is the slide taken from Tarapur 3 and 4, where we have used in a limited manner 3D modeling. But at Kakrapar 3 and 4, we have evolved we have gone for full-fledged 3D modeling. But in future project, entire plant is 3D model, and that is a very good step for responsive project management. From the model itself, we can take out the drawing, bill of quantity, we can make packages. So all those benefits are there. Classes can be tackled nicely by 3D modeling, and this is a part of the program. Here Dr. Kakotkar has gone away, but this is a photograph captured from Tarapur 3 and 4 when Dr. Kakotkar with Dr. Kalam was there to motivate us. You can see that advancement in technology has taken place during the construction itself. So slip form shutter, climbing shutter, all those things were used, and these are going to be these are the past practices which are being followed in future reactors. So that is a part of the responsive project management. So horizontal and vertical construction we have practiced in past. What happened that in earlier past we were concentrating only on reactor building. So progress on reactor building was coming, but other buildings were not coming. So it was finally adding time to the construction of the project. So that has been taken care. We have to go for vertical as well as horizontal construction so that uniform progress should happen everywhere. Pumping of concreting has been done at Tarapur. Same thing is repeated here. Only thing is that in future we are going for optimization. That computerized batching plant. Then these mixtures are also qualified in a computerized manner. So all those benefits are there. So quality is superb. You cannot doubt the quality. That type of benefit is there. We have to go for parallel working. We have gone in parallel working. Same thing we are repeating in future projects. Then open top construction. At Tarapur, we have done the open top construction and we have saved lot of time. Same practices as a responsive project management, you can say, is being repeated in future projects. So things are now getting, all procedures are laid down now. They are available for future generation and they are able to use. And optimization of time is taking place. Similarly, steam generator, which have been installed by open top construction. Precision fabrication, this is also example of how industries have done a marvelous job with best quality. And then modular construction of gas insulated switchyard that was done at Tarapur itself. It was constructed only in 5 months' time. And we have to do a practice of doing mock-up for the critical activities. And then parallel working inside the pump room. So that is also a good practices of responsive project management, and same thing is being repeated in future projects. Now, this is the example of parallel commissioning, and then contingency plan. In responsive in project management, we have to always look for contingency plan, because if you are stuck at from one path, we have to adopt another path so that timeline is not affected. This is the chart prepared at the time at Tarapur 3 and 4. At that time itself, we use the project management software like Primavera MS project. And the beauty is that if you list the constraint and uh, monitor the constraint, resolve the issues, your timeline will not change. Rather, you can save time. Even when you have got overriding priority of nuclear codes, then so many reviews by regulators are there, still you can save a lot of time. Now this is the special layout of taken from this Primavera slide. At that time we were using, and now in future we are going to use in a big way. Top red one is the baseline, and the next one is projected progress, and the bottom one is the actual progress. If you project like this, you can have at your screen everything available where the project is going, and for each activity you can have supply constraint, design constraint, site constraints, regulatory constraint, or any constraint you can list down. So that was practice for 30,000 activities at Tarapur 3 and 4. Now this practice we are going to repeat for all future projects. So this is a optimization process, and since these things are available on local area network, so it is known to everybody. So in the organization, at least one person will be there who will take action. What happens that many time one person is not taking action, and if he is not known to higher ups, he will also not take action. So that type of method we have adopted. If this type of constraints are put through software on the local area network, which was done at Tarapur 3 and 4, at least one person in the organization will take action and your problem will be solved. So through new project management software, there is a provision of sending email. If if threshold is defined, if threshold is crossed, email or SMS will come to your mobile. I think many industries are already following this. Many pictures are captured. So all those good practices in the form of new method of project monitoring has been there, and that NPCIL is also going to now adopt this. These are just example of S curve, which we have followed at Tarapur 3 and 4, and now in future project also we are going to follow. So red one is the target curve, and the blue one, which is not visible, exactly we match the target in case of civil job, and similar thing was repeated in other packages also. And below is the financial curve. Here also you can say that almost it was matching. So this is the process of optimization. Whatever you plan, exactly you stick to that, or you can do better. So that way we proceeded. And this is the primary piping package. Just I am giving example. Here also you can see that red and blue. In the beginning it was going down, but later on it captured the progress. So this type of day-to-day monitoring, weekly monitoring, monthly monitoring, all those things reveals, gives you a chance that even when some deviation is there in the beginning, you can capture the progress, crash the schedule, and meet the target. So these are the examples from where we are going to have in future all responsive project management. Now, project management is not limited to progress. We have to take care of the persons who are working for you. So, 1 million man hours generally in such a large project's work. So, we have to take care of safety aspects. So, for that, actually, there are many project software tool. It decides how we train the people, how we interview them, and what is the final this safety parameters which have been achieved. So you can see in the next slide frequency rate of accident, which have been kept very low at Tarapur 3 and 4. At Kakrapar, this was made almost zero. and in future we have got aim to keep it zero. Now, quality assurance is also a very important part of the project management. Three-tier approach is there. Now, here also there are many software available, and so our past practices have been captured, and those things are going to be implemented for future projects. Now, green belt project management now involves green development of green belt also. So that's why this slide is there. And at Tarapur we have done. In future projects also we are doing this. Now we have to also take care of welfare activity of public at nearby area. So that already has been talked. And this also I want that this should be captured as a good practices, and it should be also monitored in the as though it is a type of project. Now, what we have seen, we have done at Tarapur 3 and 4, you can see we have practiced now at Kakrapar 3, 4 also. So, this is the ring liner. At Kakrapar, actually, liner has been added in the containment. So, you can see here that entire liner has been made outside, and in a modular way, it has been lowered by the crane, and we have saved time. And there is a possibility to reduce reactor building construction to even 3 years. Now, entire dome at Kakrapar 3 and 4, weighing 355 ton, has been just fabricated outside and lowered to the reactor building top. So this is a new. Earlier we have done open top construction. Same thing has been done here, but the new two addition has been done. That is a ring liner and dome, and same thing has been repeated in unit 4 of that was of unit 3, unit 4 of Kakrapar 4, then RAP 7, RAP 8. This has been repeated, and now same thing has been repeated at Kudamkulam 3 and 4 project. Actually, in 1 and 2, this practice was not followed, but having learned from Kakrapar 3 and 4, there was a confidence and optimization process, and this was fabricated outside, and entire dome has been installed. And in Kudamkulam also polar crane. In Kudamkulam 1, 2, polar crane girder was an issue, how to install it. It took a lot of time, but here by open top construction, this polar crane girders have been, you can see the brackets, all those things are getting installed. Then also for turbine building deck, rebar cage, entire cage have been just assembled outside and put to the position. Similarly, you can see that we are going for mega pores. At Tarapur 3 and 4 also we had mega pores, but we increased that volume, and now 5,100 cubic meter mega pores in RB3 was done. And at Kudamkulam you can find that we have gone to 11,050 cubic meter. So by optimizing the design, by taking care of the heat of hydration, by lowering the concrete temperature, all those things are possible. And of course, having large batching plant, placer booms, all those things, these things are possible. So this is a, you can say that optimization process and a part of the responsive project management. Everything has been learned from the past, captured and implemented for higher volume of work. This is the mega pores done at Kudamkulam. You can see that 11,050. So this is a classic example. What we have learned has been implemented for the bigger pores. Packages, so many packages were that at Kakrapar 3 and 4, 20 packages. I have not put the number, supply, EPC, site package, fuel handling system. But now we are going to optimize because we are going to have reactor in a fleet mode manner. So we want to have only now 2-3 packages. So in a carefully manner, conventional island package, the nuclear island package we are combining. Perhaps we may go for hardly 2 mega package and few long delivery items packages. Then bottlenecks and issues. Here I will go short. There can be bottleneck issues in pre-project activities. So that anyway through our experience we are going to tackle, and we with the help of everybody, it should be possible. Interface management is very important topic. That problem we have faced at Kakra Part 3 and 4. Now by going for mega package, these issues are being tackled. Now, limited supplier and contractors we are having, because we have experienced that once in nuclear field, there are certainly limited supplier and contractors. So we have to explore that they should be always available for us, and we should also try to develop more suppliers in conventional field. Then vendor development for continued supplies. This is also long-term association has to be there with vendors. So this aspect we are they are the real bottlenecks. So we are trying to see that. Then industry preparedness to handle mega projects. That aspect is also important, but because so many fleet mode reactors are there, we have to see how many industries are coming forward to participate in mega packages. Then long lead items in a large manner. For example, so many steam generator at a time we are ordering, so many NCL at a time we are ordering, and with that we are maintaining continuity of the program, and long lead items are available well ahead of time at site. Now, strategies. So you can see in this slide, earlier we were having 20 package left side. Right side you can see that only 2 packages we are planning with some FIM, and a concept of owner's consultant is being brought, so that in nuclear sector we have got full expertise, and we can finalize the specification, design, or anything. But in conventional system, we want to have now owner consultant, so that in EPC package, if natural draft cooling tower design is offered, and IDCT design is offered, or some other conventional system design is offered, it should be proof checked by the consultant. Then our own owner consultant can check. These type of concepts we are bringing now. Now, this is the last slide, project contract model. Actually, I will not, this covers all aspects you can see in the last, but we are migrating from list cost selection to quality cost based selection. This is very important. It is a topic of debate, but it is required actually. So, quality cost based QCBS system we are going to have now. It will drive competitions, but we want to deal with only those industries who are best in quality. So this is the new feature which is going to come in future fleet mode reactors. Then thrust on technical and quality parameters of a stakeholder. So automatically, if one is done, first is done, this automatically comes. But there will be certainly thrust on these aspects when we are executing the projects. Then timely decisions through responsive project management will certainly lead to timely action, and that will lead to project progress moving forward. That we have seen even in the case of COVID-19, we have progressed. So timely decision making is very important, and through by simulating all past practices, by in the software which tools are available, we are going to use those things in a large way. Our decision making will be timely, and that will lead to certainly fast progress. And then last item is digitization. This we are looking for in a long way. 3D model of entire plant is already done. Project management tool like Primavera MS project is already in place. Product life cycle management for design is already available, and it is being used in large manner. ERP we are going to have. So with all these combinations and many design softwares already we are using, we will certainly have responsive project management for our all present and future projects. Thank you.
Thank you very much, sir, for your very insightful presentation and getting into the granularity of the issues and the solution that you have proposed. And for those beautiful photographs, it really makes a lot of sense, and it gives a lot of insight. What the nuclear industry and nuclear power NPCIL is particularly doing. So thank you for your address. Now, moving to our second address of this session, I would request Mr. Avinash J. Gaikwad, who is head of Emerging Regulatory Strategy Division of Atomic Energy Regulatory Board. Sir, please request your presence on the dais.
So I'm thankful to the organizers and good afternoon to all the dignitaries from DA, from NPCIL, from BRC and various DA units, my dear friends and colleagues. So I will be talking about mainly AERB, how it functions, what are the processes, and then we see that emerging regulatory strategy division. It is a new division which is formed recently, maybe 1.5 years back. So to take care of the new technologies which are coming, or the advanced reactors, or the SMR kind of reactors, or isotope reactors, and there's public-private participation. So those kind of proposals are coming. So, and we already have so many reactors operating with NPCIL. So regulation is in place. So to see if the regulation has to be different for the emerging technologies or same, we are working out the strategies. Then the Research and Document Development Division. So this division is responsible for making the rules, the codes and guides. So it says how the regulation process has to be taken forward. So these are the content. The first part is about AERB, organization, and the regulatory process. The second part is about emerging technologies. So new, advanced, innovative, and maybe in this jargon, all the reactors are covered. So what is the how AERB will regulate? So there are many advanced reactors or many SMRs coming up. Maybe around 70 concepts are there, and already 5 or 10 types of large reactors are already operating. So those are very well regulated. The regulations are very well known. So then how AERB is going to regulate these reactors? So it is very simple. We go by the fundamentals. So based on the safety fundamentals, we say the reactor is to be controlled, the fuel is to be cooled, and the fission products which are there in the fuel are to be confined. Then with SMRs and new reactors, is there any enhancement? So, and how we ensure that enhancement is more safe? So what is the expectation? So that we'll see. So when we talk about fundamentals, and then physically when we see that, we'll see that what are the releases. So what is the impact on the public and the environment? So these are the releases of fission products, which rarely takes place when some accident conditions are there. So, and these are to be taken care in the design. The operators can do something, but not much if the design is not so done. And what is important is cooling. So the passive systems are very handy when it comes to the cooling. So this is the presence of AERB in India. We are headquartered at Mumbai. Then we have regional center at Delhi, Kolkata, and in Chennai also. And we have a nuclear safety analysis division. So last 8 years I was a part of that division. And then we have a safety research institute, which is another division of AERB, which is located at IGCAR in Kalpakam. So the confirmatory research and the anticipatory research is taken care by nuclear safety analysis and nuclear safety research divisions of AERP. So this is the vision. So it has to be read as it is. To ensure the use of ionizing radiation and nuclear energy in India does not cause undue risk to health of people. So any business, any activity, industrial activity we are doing, there are some risks. So the risk should be like taking it worth. The benefits are more and the hazards are less. That is what is the job of AERB to ensure. And that is done throughout the life cycle of the nuclear power plant, starting with the project and design and siting stages. The vision is to be a knowledge organization. So how we can make sure we should have all the risk information. So all the technical information, all the scientific information is required. So all the national and international standards are referred before we do the rule making. Based on that, we develop our codes and guides and the requirements. So there has to be a professionalism, credibility, transparency, and accountability. So these are the virtues of any regulator. And by nature, no one likes to be regulated. Like we have the police, which regulates the public. We have the traffic inspector. So nobody likes them. But nuclear regulation is quite different. So it is science and technology based, rule based, and it has all the virtues which were there in the previous slides. So it comes from the top, from the government. So this national policy, it was talked about in the previous lectures also. I'm thankful to my previous speakers. Then AERB can issue more directives and orders. Then what next is the safety codes or safety standards. So safety codes is the word used by AERB. This is mandatory requirement for the design. And then safety standard is the word used by IAEA, International Atomic Energy Agency. And then we have safety guides. So this also at times can have some mandatory requirements, but mostly it is telling how to meet the requirements given in the codes. And then if we want to go into little bit more details, then we have the safety manuals or technical document kind of things on all the topics. So any industry should go like this, right from the birth up to the grave. So cradle to grave is the approach. So siting, construction, commissioning, operation. So all these activities are covered by AERB. So AERB will ask the utility to make submissions for the siting. The design should be ready, and then how it performs in the transients and accidents for all the systems. The safety analysis should be submitted. So what is the impact of the reactor on the environment, and what is the environmental impact on the reactor, whether a safe case is there or not. So a lot of submissions are there from the utility. So it may start a few years before they really want to go into the construction. Then during the construction also, so in all the phases, regulatory submissions and regulatory inspections are there, because we need all the knowledge. And like in the previous presentation, Sharan ji has brought out all the aspects. They have all the technology, all the good things to construct the reactor. But at some in some occasions, there is time lapse. So people want to hurry up. So who is going to see that? No lapses are taking place during such conditions. So that is the job of the regulators. Though all the technology is good, but they are doing it correctly is monitored. It is overseeing, it is not hampering anything. Then during commissioning also, whatever was promised, we see those numbers in the commissioning. Then inspections are there, submissions are there. And during operation, there are periodic safety reviews and regular inspections. Some surprise inspections are also there. And decommissioning is the responsibility of the operating organization or the government. So, then we see that there are a lot of things. So AERB deals with ionizing radiation. So from hazard point of view, we can see the X-rays, the hazard is very less, but the number of equipments are in lakhs. So, and then we have industrial radiography. We can see a smaller dot. The hazard is little bit higher. Then gamma ray chambers, irradiators, and then the nuclear power plants. So it is only the potential hazard. So we allocate resources based on the safety significance, and we are not looking everything into the details. And this is the there is a board at AERB and there is a secretariat at AERB. So chairman AERB is part of both, and he's heading both of them. And then we have our executive director. So after that, we have certain divisions and groups. So what is important is the safety analysis group, the Safety Research Institute, then emerging regulations which we are looking into. And then we have that nuclear projects or new projects division. So it takes care of all the projects which are coming. And then operating plants division we have. So it takes care of all the units which are operating, which were mentioned by earlier presentations. Then at the end, we can see the R&DD, which is Resources and Document Development Division. And we have Directorate of Regulatory Inspection, and so on. So these are the international collaborations we have with the Russian Federation, with USA, France, and then these are all regulators. We have collaboration with IRSN also, which is an organization like BARC. So we have an agreement with collaboration with BARC also, and it provides technical services to AERB wherever we don't have in-house capabilities. Then we participate in the IDA activities, and at the end we can see the OECD research kind of activities and regulatory activities. So safety of nuclear installations, CSNI we call. So latest developments on research is seen in that group where India is now participating. Earlier we were only observer. So these we have already seen. AERB is looking at all the facilities, the mining, milling, fuel fabrication, heavy water plants, and these are the power plants, reprocessing. And this I think we have already seen with NPCIL. These are the projects. These are the upcoming projects. Okay, so this is about the radiation facilities. So a lot of efforts. The Radiological Safety Division is one of the biggest division at AERB. So it regulates, other than nuclear power plants, whatever radiation facilities are there in medicine, industry, research, and agriculture. Okay, so basically these are the functions of AERB. So the complete life cycle is covered with the codes and guides. And during operation also there is the oversight. And AERB is looking at industrial safety of DA units because some nuclear element is always there and graded approach is always followed. So I think again this slide summarizes the functions of AERB. But on the right, we can see the regulatory safety research and analysis, stakeholders consultation, legal support, public communication and outreach. These are important aspects, national and international coordination. And this is again about safety analysis. So what is important nowadays, everybody knows about the design basis accident. When we joined DAE in 1998, so everybody was talking about LOCA, loss of coolant accident. But now everybody knows severe accident, Chernobyl, Fukushima, and TMI. So there is a lot of tools and analysis required to study those accidents. Then if we have a zircaloy cladding, hydrogen generation and distribution, so this is a big issue which needs some analysis and some research also. Then the possibility of releases, the probability of releases is seen by the probabilistic safety analysis at level 1, 2, and 3. The reactor physics is most important. In fact, that is the starting point. Then there are some experimental facilities and thermal hydraulic studies. So heat transfer is one of the most important challenges. So which we'll see in the coming slides. The structural aspect, fire safety, the seismic safety. These are very important for siting. Okay, so this is briefly, quickly I'll try to cover about how regulation started. So those were the days when the technology was being demonstrated, and there was, I think, hardly any difference between a physicist and an engineer. So all the roles were taken by Dr. Homi Jahangir Baba, and he had a lot of vision. So because of that, and the motivation to show that we can achieve something, although there was no formal safety review and clearance of a Apsara reactor, which is the first, all the safety features that were required in the research reactor at that point of time were present. Okay, so and these are the statement. We have to read it as it is. So the second one I'll read. Radioactive material and sources of radiation should be handled in atomic energy establishment in a manner which not only ensures that no harm can come to workers in the establishment or anyone else, the public also, but also in an exemplary manner, so that to set a standard which other organization in the country may be asked to emulate. So I think only the airlines and maybe the pharmaceutical or food industry and the nuclear industry goes to those kind of standards. So if everybody wants to join nuclear energy, it's better to elevate the standards, because the consequences of failures are going to last for hundreds of years, if not thousands of years. So this is how the regulation started. The safety committees were made, and indigenization, which is another important factor. Indian made fuel, nuclear fuel. Okay, so that was about the evolution of regulation in those days, and everybody wanted to prove a point and achieve something for the nation, and they were responsible for regulation as well as design of the reactor, as well as construction and doing everything which is required. But now when we talk about the emerging technologies, which are the small and modular reactors, so many concepts, do we have that kind of environment where a physicist and engineer were one in all? So those kind of people we are missing nowadays. But anyway, because more of specialization is taking place, the engineers are 10 kinds of engineers are there. Physicists are also divided into many, and many of the physicists are not interested in reactor engineering, reactor physics. They are more interested in doing high energy physics. Okay, so this says we have to be self-reliant, and that NPCIL and DAE has achieved that by development of the PHWRs. So initially it was demonstration with the help of Canadians, but then MAPS, NAPS, CAPS and KGS onwards, and now it is the 700 megawatt reactor which is available. And at the top right we can see the commitment from our Honorable Prime Minister, and then this we'll try to achieve with both the ways. We can have indigenous also, and if the imports are justified, maybe some of the utilities can have the imported reactors also. So for this, if the program has been expanding right from the beginning, but the rate of increase was a little bit smaller, but now it has to accelerate. So everybody says nuclear is must, and we have to expand and we have to deploy very quickly. How that can be done? So you need resources. So financial resources is one thing, the human resources. So the way the nuclear power is expanding, AERB also has to expand. It has to have its resources. So we are getting our resources from the training school of BRC, which is one of the world-class institute. We take directly from the IIT MTechs. Then we take experienced professionals from directly from industry also. And then lateral entry, I'm one of the example. I was part of BRC for initial 23 years of reactor safety division, and last 10 years I'm part of AERB, and there are many more colleagues I have like that in AERB. Then the next is the training part, and AERB is open to gaining knowledge, and these are the numbers we have right now, and they are quite good for the number of nuclear power plants we have. but we find sometimes it is demanding to regulate the that radiation facilities, which are in lakhs in numbers, right from X-rays. Though X-rays have very low potential, but overexposure cases have been seen in those low potential hazard areas only. In the nuclear power plants, we don't have overexposure cases as many. So these are the documents. So thematic topics are there about regulatory process, radiation protection, emergency preparedness, NPP designs, siting, NPP operations, and radiation facilities. And this is the way when a submission comes to ERB, it is going through a multi-tier review process. And maybe in the beginning, it is the ERB staff, the working groups, the task forces, and expert group. Then it is the first tier, the safety committees. Above that, the advisory committees. And at the top is the ERB board, which finalizes the decisions and review comments. And we take technical supports from retired experts of DAE wherever it is necessary. And there's a big pool of experts available to ERB that way. So we had the IRRS mission, that is a peer review mission, which says whether ERB is doing its job properly or not. So we had that in 2015 and 2022. So we can say that we are independent. Functionally, we are independent. We don't have to take orders from anybody. We can look at the safety case and make our decisions based on sound technical and scientific knowledge. Okay, so we are open. I cannot hide whatever review and comments I am giving on the submission. I have to make it public. Then we have to be just and fair. The credibility and trust has to be built. So how all this can be done is I should have the risk information, all the information from the deterministic analysis, from the probabilistic safety analysis. So I don't ignore the stakeholders. They may have some concern, which I may be overlooking. So that way I'm inclusive, I'm flexible, and specific to the safety case, I focus on that and make the decision. So this may be like calling it very tall order or talking too much, but if we don't target 100%, we may not be able to achieve 99%. So the IRS mission also had a similar kind of conclusion that ERB is a capable organization. It is doing its job. And the previous one, the statement in 2015 was India's Atomic Energy Regulatory Board is an experienced, knowledgeable, and dedicated regulatory body for the protection of public and environment. So this was the team leader, Dr. Ramzi Jamal. He is a Canadian and well versed with the CANDO and PHWR technology. And then there was a follow-up mission. Okay, I'll not go into the details. So the findings were quite positive. We can conclude the last bullet says, in 2015, there were 13 recommendations in spite of all those good comments and 21 suggestions. And in follow-up mission, 11 recommendations and 20 suggestions were closed. And there were no new findings. And whatever suggestions or recommendation remains, those are very of minor kind of things. So then once we make the rules, we have to see that we are updating them, we are harmonizing them, and in that process we are simplifying them also. Where somebody may say these rules are too cumbersome to follow, then we are taking the inputs, and at the lowest level, the staff will be looking at it, then it goes to the committees, multi-tier review, and finally it is approved by the board, and it goes into the codes and guides. So finally, coming back to this is the second part, follow-up. So we also look at what are the developments in SMRs. So coming back to fundamental safety, so control, cool, so cooling, heat removal, that is at the top right, we can see that this part, I think everybody knows that nuclear is different. There's no limit to the heat generation which can take place. But heat removal is the design capability of the nuclear power plant designers, and they can The thermal power plants don't have that kind of challenges. 0.5 to 3 maximum kilowatt per liter. The gas cooled is 5 kilowatt per liter. PHWR is 10 kilowatt. So this is also on the lower side. But water cooled reactors, BWR, PWRs, up to 100, we can see that number. So in a very small space, a very high amount of energy is released, and the heat, it comes out as a heat to be removed. So fast breeder reactors, the reactor core is very compact. So there we have even bigger challenges. So how these things are controlled? So there is a linear heat rating is one of the aspects. The critical heat flux for water cooled reactors, and a regulator will like to have a hold on the third parameter, the heat transfer area per meter cube, or maybe whatever surface area is provided for the fuel. But directly there is no hold point, there are no regulations. It is left to the designers that they are not violating the temperatures, accidents are not taking place, fuel is not getting damaged, and that indirectly everything comes down to control of the neutron flux, which controls the rate of heat generation. So a lot of controls and hold points will be there on the neutron flux. But other things are like the decay heat is to be mentioned, which is not there for any conventional fossil fuel, even if you shut down the reactor. So if you don't control the reactor, it can go to infinite power theoretically. Practically, it can melt the core. It can be a Chernobyl kind of accident. But even if you shut down the reactor before that thing happens, and you don't remove the decay heat, which is 7% to 1% for days, then it is capable of melting and causing Chernobyl and Fukushima kind of releases. So this is the way the fission products are getting out from the primary system, coming to the containment atmosphere, and from containment either a bypass can be there because of accident, or leakages are there. If the leakages increase, then they are going to environment, then they are going to the people and the atmospheric dispersion, and finally they are delivering the dose. So what dose we public can get, there are hold points on that, limits on that. So next is the source term. So initially the philosophy was worst conceivable accident. That was long back. Then people said some of the accidents are not credible. Okay, so that was taken, and exclusion zone was reduced. Then next was the approach of the generation 2 reactors, which said the only design basis accidents have risk, and we need to focus on the design basis accidents only. So the protection systems were strengthened, and then this philosophy has come that we have normal operation, defense in depth level. So DID is one of the most important concept. We have multiple defense layers. So even if one is breached, the second is there. Up to 5, we have 5 levels. So normal operation, we design the reactor in such a way that it doesn't go go away from where it is indented. If I have maintaining a temperature of 300, it will remain around 300 plus minus, very small. But then I follow the very good design practices, design standards, and I select very good material. I select very good concepts where reactor physics, thermal hydraulics is concerned. And I select a very good material so that my vessel doesn't fail. So vessel failure is a severe accident, but that is covered in DID level 1 by selecting and designing the vessel very strongly. The next is anticipated occurrence. So here control will come first, maybe protection in some cases. Valves, pumps can fail, malfunctions. Then the design basis accident like loss of coolant, break of cooling pipings, then rod ejection, loss of flow can be there. And for that, we have safety systems like emergency coolant is provided. Maybe multiple shutdown systems are there. Then what is the next is DEC, design extension condition, which is about severe accident. So it is divided into 2 parts. So one is with without significant core melt. Okay, and then other some significant core damage can be there. So I cannot cover everything because something will be beyond that. Accident at the top, we can see it is going to the end. So I have to practically eliminate. I have to see that to what extent I can take care, to what extent I can add complementary and additional safety systems. So I add systems like containment cooling. I provide a very big containment volume. Then I have this filtered venting. Then I can have a core catcher. I can have the debris cooling. So mitigation is another thing. Prevention is another thing. So up to DBA, it was all about preventing the severe accident. But once the core is damaged, then I should not be running away from the reactor. I should have some means, because then only the fission products will start coming out. So I have to confine those damaged core. I should know how to handle. I should have provisions for handling the damaged core. So this is the risk perception, the frequency of occurrence and consequences. 10 minutes. 5 minutes. Okay, I'll do this by 5 minutes. Okay. So
some people there's a panel discussion later.
okay. Okay, so I'll quickly go through. If the curve, the philosophy was like when the curve is going down, at the design basis accident, there is maximum risk. The consequences and probability is maximum. So I added maximum safety systems there. But afterwards, what happens, I really don't know. So the regulator has to know what is happening. So all risk information should be there. This is all about accident which I am not covering. So these events are practically eliminated. I should have the number for them, and then I should be making provisions on the other side, lower side of that. Okay, the next is about the generation of reactors. So here the question is, if we talk about SMRs, which is the generation? From safety point of view, I am not talking about economics, and regulators are not supposed to talk about that. So which generation? So we expect at least generation 3 plus, maybe generation 4. That kind of safety features are there with SMRs. Then if I'm making a new reactor, what is the motivation for me? Just I have a bigger reactor, now I want to make a smaller reactor so that public don't see the dome structure there, they don't see the cooling towers, big huge structures, everything can go underground. That should not be the motivation. The motivation is whether it is catering to severe accident, whether it is depending more on practical elimination, or I am doing it properly, making all the provisions and eliminating possibilities of accident. I have a passive shutdown system, multiple shutdown system. Most important is fuel advancement. So, and the next is optimal configuration of the. Okay, so. Finish.
On that note, Mr. Avinash, thank you for your brilliant presentation. Unfortunately, it's a very interesting presentation, but we are running out of time. Fine. So, Mr. Avinash will be around. You can ask him questions. He has his presentation slides. So, let's thank Mr. Avinash for a wonderful presentation, everybody. All right, so we will quickly move on to the panel discussion. Vinay, you want to take charge?
Yeah. Yeah, thank you, Mr. Avinash, Gaikwad sir, for your wonderful and exhaustive discussion. And so now moving to the panel discussion of this session, we have an interesting discussion, regarding bringing synergy among the stakeholders for efficient program delivery of nuclear new builds. So, project phase is the most challenging and most critical phase, but a nagging issue also, because this is a time, where that pits the engineering, design, and project management prowess of the organization against the realities of the world, which reflects into interest during construction and subsequently into the cost to the end consumer. So, we have with us speakers from across different organizations. We are being joined by Mr. M.K. Srivastav, Executive Director, Engineering, NTPC. Mr. Vakis Ramani, Senior Vice President, Development and New Nuclear Projects and Engineering, EDF. Mr. T.T. Mani, Managing Director of Serala Technologies. Mr. Praveen Bhatt, Vice President and Head Nuclear Business, Larsen Tobro. So I request all the distinguished panelists to join us on the stage, and I welcome you all. So please. I welcome all the panelists here on the stage, and just as a briefing for the panel format, we will be going with the opening remarks of all the speakers, and then we will get into the deeper aspect, and then question answer session from the speaker from the audience, and then finally, if we get time, a concluding remark. So. The panelists are entitled to have their views, and then they can share their own experiences, and then finding of some case studies also to make it valuable. So starting with Mr. Srivastava, sir, what are your opening remark on efficient program delivery of nuclear power projects? Mr. Srivastava.
A very good question. I think Mr. Sharan has rightly presented the entire spectrum of project management of nuclear project, and he has also discussed the improvements that has been taken care of. But the objective is only one. That is, whenever we do a planning, we do with a time schedule, with most of the known hurdles that is going to come, but of course, it cannot be 100%. There are some unknown hurdles that will come. And this can come from any of the stakeholders, be it the design, be it the construction, be it the people communication, be it the finance, be it the global scenario, or anything else. But the project management is all about that only. Project management has to be very dynamic, and it should be flexible, so that as and when the issues come, the people at the right place, they can make the choices based on the data, information, and things are taken back into the course of action. Two things I would like to add. What the modern responsive project management, what Mr. Sharan portrayed, that we should have a simulation feature. That means a lot of resources are required, and if due to whatever been the reason, the resources are not being fulfilled, maybe with the digital techniques, we can find the better solution before putting into place. And adoption of the digital techniques, which has gone a long way into the project management, is the requirement of the day. So, with that, let me pass it on to others. Thank you.
Thank you, sir, for your opening remark. Now, I would like to move to Mr. Vakis for your opening remark, please, on efficient program delivery of nuclear power plants.
Well, building maybe on what has just been said, I will keep it very simple in saying that learning is very important, especially when we talk about Gen 3 plus reactor design construction, which are very complicated, and the level of complexity is significantly more than the Gen 2 design construction phase. And so, on that regard, what we feel, and we have learned at EDF, is that the best thing that can happen for learning organizations is that you have a pipe of project that is sufficiently robust, where you can capitalize over time very quickly. In our case, for EPR reactors, we have practically seen first decision making for the first of the EPR that we have been building in Flamanville 3. That first decision was made in 2004. Very quickly thereafter, we have managed to launch another project in China at Taishan. And the learning of the first project into the second allowed really the second project to move very fast. But this was, one project was in Europe, the other one was in Asia. The construction teams were completely different. It was the French industry building the one in Flamanville, and the Chinese teams building the one in China. And clearly, while we could capitalize theoretically what has happened in China, of course, it's not the same welders, the same constructors we were working in Flamanville, completely different. It's not the same industry at all. And eventually, in Europe, the second project we launched after Flamanville 3 was 12 years after, and that was in Hinkley Point C in the UK, and this is a plant which is currently being built. And so if you look at the situation of Europe today, it has taken Europe as a whole 12 years between the first decision and the second decision to launch construction. And this is definitely harming the capability of learning of any organization. So obviously, when we talk about nuclear, we cannot do that just as an industry. It's not just an investment decision that we make. This involves significant government implication. We need decision makers to be fully aligned, to develop policies in the long term. And as part of their policies, we need them to provide the industry sufficient visibility so that they can effectively plan also on their learning and capitalization processes. And we're facing it today, and you all know that in Europe the situation is very difficult currently, energy crisis ongoing. It has a worldwide impact, but it is harming us directly in Europe currently, today, with not enough reliable power available. And as a result, a number of governments are making decisions and are launching programs. And in France itself, we have a 6 EPR program being launched. In the UK, there are additional 2 units being launched. And we have recently put an offer in Czech Republic for up to 4 units program. So we can see these happening, and those are, I would say, the absolutely key element to ensure successful construction, which is ensuring that you have a robust pipe and ensuring that the organization have the learning capability in a program where the different projects are not decided with too many time gap.
Thank you. Thank you for your remarks, Vakis. Sir, I would like to move to TT Mani, sir, for your opening remark.
Good afternoon. As probably all Dr. Kakotkar sir was mentioning, Dr. Sharan sir was mentioning, the cost of the project depends upon the time schedule. Particularly in our country where the interest rates are higher, the cost totally depends on that, and also loss of opportunity of selling the power if project gets delayed. So for these things, as Mr. Ramani was mentioning and also Mr. Shivasa was mentioning, the project management and knowledge, whatever we have gained, how we can use that for ensuring that projects are, kept the time schedule. Like when Tarapur we could achieve in 4 years, 11 months, why not others? And also, fortunately for all of us, that's both for the developers as well as the industries, we have got a lot of opportunities ahead. Almost about something like 12 PHWRs are there, which are going to be, started, construction. And also, a lot of opportunities from the foreign reactors are also going to be there. For these things, my sincere request is, if we can have, with the experience of whatever we have gained, a brainstorming session between NPCIL and also the players who are going to be there, like industries and EPC contractors and other things, how we can ensure the timing. So without any commitments, at least those information can be quite useful. Try to keep the project schedule, and if that can be implemented, that will be really great. So this is what my opinion is. Thanks.
Thank you very much, sir, for your remarks. Now I would be moving to Mr. Praveen Bhatt for his opening remarks.
So good afternoon. In first session, I think we agreed that with present global energy crisis, nuclear is the solution. And India also had an accelerated growth plan for nuclear power. We are saying 22.4 gigawatt by 2031. And the biggest challenge we are facing, I'm agreeing that biggest challenge we are facing is the schedule. All our program, and that is also changing perception of industry, whether they should invest, they should come forward or not. So biggest challenge right now we are facing is the timeline and project management, how to control the cycle time and then further reduce cycle time, because 5 years is also, we have to further reduce. Whatever experience we are doing our bit in a long lead item like steam generator and NPCIL for Gorakhpur program. We delivered 12 months ahead of schedule in spite of all those pandemic and all those things. So what is our learning that? First is that freezing of specification. That is must. We say in industry, improvisation during execution is the enemy to cycle time. If you keep on doing improvisation, there will be some necessity. But try to see that you are freezing the specification, freezing the quality assurance plan, establishing reliable supply chain. Every time if you are going to new, when we decide our supply chain, we go by what is their track record, past track record, how they have delivered, how is the technology he's having. So establish supply chain. Then use of technology. See, industry is changing drastically. We are seeing in other part of thing other than nuclear, cycle time and reducing to half. How? By technology. Technology in manufacturing, technology in project management, technology in ND, automation in ND, automation in every aspect of the thing. So use of technology is must. We are very thankful to NPCIL. They are coming up with these ideas. When we pandemic faced the problem, they were there to support us in use of technology for inspection and all those things. So these are the key things which we should address. If once a project is delayed, all this debate whether nuclear is viable commercially, not viable will start. And industry, we have invested in capacity. We have invested in capabilities. We have kept the best people for nuclear. Continuity is one of the most important. Again, as Mr. Ramani said, if continuity is there, you will get the benefit. Otherwise, industry will not be able to hold those capacity and capability. They'll move to something else. So with a PSWR program, fleet program, these things are addressed. One more aspect is very important in my opinion for cycle time reduction, modularization, which NPCIL is working along with the industry, and we are getting good benefit, good success in some of the program. Mega project is one of the new theme. Again, I'm saying, which is the strength of industry? NPCIL should use that strength of industry. Project management, vendor management is our strength. Industry's strength. So those things should come to industry. They can deliver. That is my initial thought.
Thank you. Thank you very much, sir, for your remarks. Now, the important point of our discussion is also, bringing synergy among stakeholders. That means basically, to have a better coordination, because this is also an important part of the this program delivery. So moving to our second round, sir, I would like to have your your thoughts on this. How it can be done? How to be specific? If you can please elaborate with some specific points.
Yes. See, every stakeholder in a project has a defined role. And if that role is played correctly and timely by that stakeholder, his contribution to the project is, if not 100%, very near to the 100%. And this we should understand. As I have said, there are various stakeholders in a project. Now, there are a few fundamentals. Nuclear project is a long project, high intensive cost is there, and so when we start the project, first of all, that ownership has to be there, that belief that it is my project and I will get it done. It is not that it is NPCIL project or it is NTPC project or it is somebody else's project. Those team, they should have the belief that it is my project. And that belief is, if it is there, then I'm sure, then whatever the problem comes, there will come up some out-of-the-box solutions and things will get solved. But much beyond that, with respect to the carrying out the project with the time schedule, every stakeholder, when the day starts, his job for that day should be clear to him. That before the day ends, what is his task for that day? And at the end of that day, then he can decide himself or herself whether he has done his bit or not. If this type of project management or stakeholder management and the stakeholder responsibility, accountability is being carried out, there is no doubt that we can complete all the projects in time, not only in time, if we go further, I'm sure we can do it before time. Thank you.
Mr. Ramani, for your thoughts on this, because I think you can share your international experience also on this.
Thank you very much. I very much like the idea of ownership. The idea of ownership is absolutely necessary, given the number of stakeholders. I entirely agree with that. And the idea of ownership comes together with the idea of responsibility. Responsibility is at the core of the success of the different of our projects. And given we talked about the complexity of this, this is absolutely necessary. What we see happening with a number of stakeholders is that not only development cycle is very long, between the time you have the idea of the project emerge and the moment you start breaking ground, it takes quite a long time. This is the time required to align all the stakeholders, governments, industrials, contractors, all the aspects, permitting and all. And during that time, there are a lot of discussion around who should take what kind of responsibility. And in many cases, I would say we waste time in having the wrong discussion onto trying to push the responsibility on somebody else. In a way, when we look at it from a paper standpoint, on the paper, it's pretty straightforward. We would want the capable entity taking over the responsibility for the scope it is best able to perform. That is pretty logical. So that sounds easy. In practice, coming to a contract based on that principle is extremely difficult. And there is a game which is about, no, I don't want to take this. So maybe you try and take this, but maybe not. And there is always the issue with the interfaces. Who takes what responsibility? So coming back to the idea of ownership, if there was sufficient ownership feeling of the different stakeholders, what should happen is that first people would not be shy of taking the responsibility related to their scope and remit. Second, they would find easy ways or practical ways to align interests to manage interfaces. And the role of the integrator could be simplified. Now, this has to be regulated in some ways, and probably, it's governments again, and other intermediate administration should support in making this happening, because what we see in many of our discussions with many parties, whether in India with NPCIL or in other countries with chairs in Czech Republic, is that most of the discussion focuses on the responsibility and management of interface. But actually, the time we waste in discussing where should be what responsibility, actually we forget in putting that time to define effectively how we should be working together. So that would be my takeaway.
Thank you. Mr. Mani.
I agree with Mr. Srivatsava when he's told the responsibility ownership which has to be there. 100%, unless that is there with all the stakeholders, it becomes difficult to achieve that. Finally, the time goal target, what has been kept, has to be understood and followed by all the people. One advantage of the recent thinking of NPCIL going with a mega package will address to a large extent that coordination and interface effects and which are all happening now. And as Mr. Bhatt also was mentioning, that the right people have to be selected for giving the contracts, because some of the times most of the items will be ready. One item, it will be for that it will be struggling and the project gets delayed. So, and as earlier also was has been discussed by Dr. Sharan sir was mentioning, our process of contract management, and in case the people don't follow that, so taking action on that, unfortunately in our country, takes very long time. So selecting the right persons is one of the most important, and the interaction initially before the starting of the thing and taking the opinions as Mr. Ramani was telling, and those things is very important to see that these things are addressed and role clarity can be fixed. That's my view. Thank you.
Thank you, sir. Thank you. Mr. Bhatt.
So I think it's a known fact that a collaboration among the stakeholder will lead to success of the program. In spite of that, we struggle. So I'll say collaboration in two different of a program will be two different. One is that mature technology like PSWR, where a program is matured and a supply chain are fixed. Their collaboration is that among the stakeholder to learning from the past. What industry have faced problem, what operator have faced problem, what regulation is facing problem. If we go back to our learning and incorporate those things while preparing tender, while preparing contract, those type of collaboration will bring a success to the program. And things like new development, SMR and new technology development, their collaboration is different. There we are saying at the starting design stage itself, we should involve stakeholder in terms of developing material, in terms of developing manufacturability, what designer is visioning, whether that is possible for industry, whether unnecessary adding cost. So their collaboration will be at engineering phase itself, design phase itself, in developing technology. So these type of collaboration will certainly bring, and accountability and responsibility, actually that is the key. If people are not taking, if stakeholders are not taking responsibility and accountability, it will be never a successful program.
Thank you, sir. So, coming to this sort of interface management, so just would like to have your insight whether contract structuring or contract management is sufficient enough, or are there any issues, which are hampering project management as a whole? Starting with you, sir. Or what kind of provisions should be there, so that it can facilitate this interface management?
I think very pertinent question. Because we understand that this project is a long-run project, So when a contract is prepared, so number one, the contract should be flexible so that as and when the situation goes something different, the contract should have the provisions with requisite clauses that how to deal with such disturbances and how to come out of that. Number two, in the contract, the clarity of role between the contractor and the developer should be very clear. Because these type of gray areas, as and the contract progresses, leads to lot of confusion and it all results into time delays. Secondly, after the project has been constructed, it has been commissioned, how to close the contract? Because if I look from the contractor's view, he has come with a purpose. So his part, if it is not seen in the part of the contract, maybe he will take the contract, but later on he will suffer. And there is a good saying that when a contract is signed, that it is equivalent to saying a developer is going through crossing a river and sitting on the back of the contractor. So if the contractor fails, both the contract and the project and the owner will get submerged. So these things have to be taken in mind. And there's a lot of learning which different projects, different companies, different contracts, vendor side, developer side, all of us have gathered. I think if we can share our concern and suggestion, we can build all these things in the contract, which will pave a way for very, very successful and timely project completion. Thank you.
Just one more question, sir, because NTPC has been across different segments of power generation. So what sort of thing would you advise for which are not there in the nuclear but they're in because NTPC is also in the renewable sector now. So what sort of things, and renewable of course we know is going in a big way. So what sort of are their contracts different than what from the project management point of view? Or what sort of good practices they are following so that those can be adopted in the nuclear sector as well?
Yes. One thing I'd like to share. See, NTPC, we are building projects for last about 48 years. And unfortunately, there are some contracts which have not yet closed. And on very few trivial issues, those contracts are dragging. Maybe problem on the our side or on the side, but I think the contractual clause is not so built up. So those things need to be addressed. And in our new contracts, we have built this. So the contractor is sure that if he's getting the contract, and if the problem comes, suppose there is some problems, the PG test or the performance guarantee test could not be happened, then there's a time defined. Within that time, if it is not done, it is deemed approved. So these type of clauses, if it is built, it will help to make the confidence for both the contractor and the developer in the contract execution. Thank you.
Thank you, sir. Mr. Ramani, if you can share your experience on this issue from your perspective.
Yeah, I think we can dwell for very long on contractual matters. I will go to to some basics, really. The reality is the contract only defines conditions at one point in time based on the best available knowledge related to a project or its future. Everybody has to understand that the contract will evolve over time, especially nuclear, where programs takes many years. What is absolutely clear is you can have the most beautiful contract on earth. If the supplier or the contractor is poor, the program will fail. So it's first and foremost based on capability. It's not based on the contract. It's first and foremost based on the capability. The second thing is the reverse. You can have the most awful contract possible, which is really non-favorable. If the contractor is really good, he will deliver. Again, it is a matter of capability. So then the question is, and I told you I like the idea of ownership, we come back to the idea of ownership where the contract is there to define a balance at one point in time. And when this balance moves, and if there is a collective view of ownership between the supplier and the client, then the contract can move properly. So you need to have proper contract managers on both sides to have this moving according to the context evolution. This is not always the case and leads to many different things like claims on one side. Sometimes the program stops. We have to find a way, in nuclear especially, to create the conditions whereby the different contractors involved and the client involved, so the responsibility of the client is definitely engaged here, are there to work for the interest of a project, and then, solutions can be found. Those conditions where we have full cooperation, we have to find a way to create them, and that's not an easy thing to do. There again, if we have one contractor and one client who have been doing many projects together, they will learn to work together. And so, of course, I'm hoping, for the example of Jaitapur, that since there are 6 units, I'm hoping that the second unit will be done much better than the first, and the third much better than the second, etc. And we will be collectively very efficient at the 6th one, which will hopefully lead to other Jaitapur type projects with EPRs in India.
Thank you. Mr. Mani.
I agree with him that the contract is only a piece of paper. Unless the right contractor is chosen, he should have the ambition to achieve that whatever customer wants. And as Mr. Srivastava was telling, that contract also should have some flexibility in case contractor suffers due to some problem, either technical or financial or whatever it is. There should be some flexibility should be there in the contract. It should be provided, so that the end goal is to achieve the timelines of the project. So these are all the very essential things which has to be selecting the contractor as well as having some flexibility to ensure that final timelines are met. Thanks.
Thank you. Mr. Bhatt, please, your
So I agree that first tool to manage interface is contract. But best interface management happened when you need not to refer the contract throughout the journey. So there is no requirement to refer back. And that can happen only if there is a good selection of vendor, established track record, and both the stakeholder understand each other. And this is the way going forward. And QCBS is the one good step NPCIL has taken towards that. Now, whatever you write a contract, whatever you do interface management, there will be change during the execution. So change management is the most important while managing interface. And again, I'll say in this also, technology is having very, very a robust platform to managing change. You see the program like ITER, nuclear fusion program, 7 countries and 1,000 of vendors across the globe participating in that program. And how change is being managed through technology. Every non-conformity, every deviation are at one place. Everyone is going and working there and putting their deviation and their changes. And these are being managed. So we have to use those aspects also for managing interface and managing change.
Thank you very much. So, ownership, responsibility, flexible contract structuring, and efficient change management are the key. And with this, now we will be moving to the question answer session. So, we would request the audience to please raise your hand if you have any question. Yeah, please.
Hello, this is Rohit from ITER project, as Praveen ji is saying right now. When we talk about stakeholders, and the stakeholders are in the form of private companies from India and private companies from abroad, And when stakeholders are government of the countries, then it becomes another ball game actually. So my question is from the answers which you gave on the panel is that you talked about ownership, you talked about responsibility sharing. There is the third word which I have experienced personally working for ITER project, the word control. So how much should control be there with the parties, with the vendors? How much control is being shared among the vendors and the stakeholders? And whether those controls are creating conflicts. So I want a point of view from all the panelists. Thank you. So taking your last part first. See, control, I'll say that you should use graded approach while controlling. It should not be like treating everyone together. Based upon, suppose there is an industry who is having an stamp holder, SME, they got their quality policy in place. So you have to go as per that. So this industry is having inbuilt control, so I can relax to that extent. I can put my control system to that extent less. And if the other industry who is doing first time, where you are struggling to establish quality policy and a quality assurance system, you have to take accordingly. And I think, as I said, you have to use strength of the stakeholder. When you are coming to private sector, what is the strength? Flexibility, decision making, faster thing. So you act accordingly. When you are having a public sector, their strength is knowledge base, capex, investment, those things. So use that. So you, based upon the strength of the industry, you have to take decision. If you are keeping all together at the same platform, you'll be struggling. One thing will fit at one place, that will not fit other place. So based upon their strength, based upon their characteristic, you have to deal while executing the program.
Maybe I can add on that. There are two things we are focusing on to improve project level control and on our suppliers. One is standardization, and in the nuclear industry, somehow standardization has been lost in the way, and we're going back there. Number two is standardization of practices. So there's standardization of components and manufacturing approach, and then of practices. Both are important, and they can help relax actually controls, because today effectively level of surveillance, especially when you have safety matters involved, is very high, and say there is a lack of trust also in some projects or in some countries, and so basically you have to go very deep in the controls. To relax all that, there is one interesting thing we are encouraging very much our suppliers to go into, which is ISO 19443. And we are, really encouraging them to get qualified, because that brings assurance to us that there is a standard practice. Of course, that doesn't relieve from any control or surveillance, or we'll continue to have that, but at least it's based on standard practice. And if that can be effectively shared with as many as possible, then we bring standard practice into the industry, and that is favorable.
Incidentally, L&T is the first Indian company which got a 19443. We just audited last month, and we applied for that based on feedback from EDF and all other international players. And then we applied and we got that certification. One.
Can I add something? See, control is a process, it is not the objective. The objective is the quality. How do we achieve the quality? And through control, we try to achieve the quality. As has been rightly said by my fellow panelists here, that to achieve the quality, it is standardization to a very great extent achieves that. And let me share with the NTPC experience. We have a quality check on control in category 1, 2, 3. One is 100% checking.
You can have a bit.
One is 100%. Is it okay? One is 100% checking. Two is around 50 to 60% checking, and third is minimal checking. Now, based on the quality that the vendor gives, and how does he improve his own quality systems, this putting the vendors into category 1, 2, or 3, this is a dynamic process. And it is our endeavor that all the sub-vendors, finally they all become into category 3. That means their quality systems, they are so much developed that no further control is required. Because control requires a lot of cost, lot of resource, and lot of time. Right, thank you.
Thank you, sir. Thank you very much.
It was a very informative and session on contracts management. Having been with the Contracts and Materials Management Department of Nuclear Power Corporation, I can share with panelists that the contract being not static but dynamic is built into our contracts as we are growing with the corporate culture. There was a time when we used to have only fixed price contracts, which obviously had problems as the conditions changed. We included price variation clause, which is equitable to both vendor as well as NPCIL. Then we had two-part tendering system where spurious people who quote just for the sake of quoting were eliminated. And now I understand from my friend Ranjay that they are building some new formula which is not only the lowest technically qualified bidder but lowest capable bidder. During our times, during Dr. Srinivasan's time, there was a committee which went into this aspect that how to factor in the other capabilities of the vendor. But somehow during the bureaucratic process, we could not come to a final implementable solution and it stayed on paper. I would be too glad to learn from Ranjay as to what exactly is the formula and if it can be shared with the audience.
Yeah, so the formula at present is 30% weightage to the technical side, technical parameter, and 70% weightage to the financial. So we are going in a, you can say that, staggered manner. In many industries, they are giving more weightage to finance, technical, 70% weightage to technical and 30% to finance. But we are going in a, you can say that step by step, first 30, then 70. So with this and for technical parameter, we have selected many components. Out of that, one component is that if you have worked with the nuclear industry, it will also have points. It's not that if you are best in quality, you will get some certain number. But if you have worked with nuclear industry, you will get certainly some more points. So that type of thing has been evolved. Thank you.
Yes. Yes, sir. Yeah, please go ahead. Yeah.
Excuse me. Myself, I'm Rambabu from ECIL. This is nothing special, but one small doubt I'm asking. Now, Sharan sir told that NPCIL is going with MECA package. Yes, it is fully appreciable to maintain the timelines. But as far as NPCIL is concerned, the supply chain is more or less fixed. Means who has to supply what, that is more or less fixed. Suppose if it is going to every package is going to a single quality vendor, then again it is nothing like shifting the responsibility of NPCIL to the contractor. So NPCIL is safe as far as is concerned, but all other small vendors, they are all crying. I think this was expressed in the vendors meet by NPCIL also. Anything can be commented on that?
See, two things you have told. Who has to supply what? That was clear. But one element was missing. When? And this will be answered by the project management.
So I also agree. Main intention is that by mega project interface management decision making will be faster. For NPCIL to cancel a contract of one small vendor, a piping spool vendor who is defaulting for 2 years, it's impossible. We have seen that. For me, I have placed the order on a vendor. And I have placed next week another order to another vendor for same item because first vendor was defaulting. So these type of decision making, project management will be faster when it is at a 1 mega project level and where interface being managed efficiently. I'm saying it's a strength of each other which we should use. NPCIL strength is different. Industry strength is different. For expediting the program, you need to use those strengths. All those packages will go to those people, but managing them, getting the work done. What is the strength of industry? Expediting the thing. And what is NTPC strength? Project management. They have done so many mega projects. So if they are managing a mega project, they'll be managing very efficiently. NPCIL strength is design, working out the configuration, all those things. So these are the idea when we are saying mega project likely to be a successful model. We have to see that. Still, first program will come. Okay.
And one more thing to address Ram Babu. Actually, earlier NPCIL was executing only 1 or 2 projects at a time. Now, the plan is that not only NPCIL, we will join hand with NTPC also in a joint venture form. We are going to have at least 10 projects running at a time. So, mega will be 10 mega project packages. So, everybody will be covered. And it is, mega package is one, but it is supported by so many FIM also. Na? So, there will be at least 10, 12 other orders which will be going to industry for long lead items.
So, thank you very much. Sir, if you would like to conclude with your final remarks.
See, during the coffee break, small discussion with Dr. Kakotkar, he told us that we are sitting on top of the mountain of opportunities because the world needs nuclear power and there's a lot of scope in the developing countries where India can take the lead. And to do that, we have to deliver a project within time, within the cost. And as has been the Indian tradition, we do a project with a world record. So with my data, I think the project, best project has been done in 4 years. So our target is very clear. We'll do a project in less than 4 years and show to the world that we are the best. Thank you.
Thank you. Thank you very much. Sir, your concluding remarks?
As we are all there together, and as you said, that opportunities are plenty now. At least we are looking that to grab that, and all of us can put efforts together and share our experiences and problems what we face. Definitely, as you said, that we can try to achieve and show to the world that yes, we can do that in 4 years. Thanks.
Thank you very much.
Yeah. So I think as a conclusion, I'll say that nuclear is getting right importance now. It was due to nuclear, and now people are looking us to deliver in time. And I'll say that NPCIL has taken right step in that direction by giving FRIT program, mega project model, QCBS, and all those steps they have taken in right direction. Industries are ready. They have developed capability. They have developed capacity. They are presently ready to serving both Indian nuclear program as well as global program. And we are poised to set a new benchmark in construction of new projects.
Thank you very much. Thank you all the eminent panelists for joining us for this wonderful discussion. And now we will be wrapping up this discussion. And now we will be breaking for a lunch.